All right. So let's see what we can do here. And here's a reasonable strategy. And you might have come up with this strategy. You try something. So at the beginning, you've tried this guy and you've amassed a reward of 1. And at any time, you can imagine that, you've amassed a certain reward, a certain average reward. So we can say that you've amassed a certain reward, average reward. And I use the angle brackets for average. So average reward for bandit 1. And there's some average reward for bandit 2. Okay. Now, any kind of deterministic strategy could lead to long-term non-optimal behavior. For example, we might say if reward 1 is bigger than reward 2, then always pull bandit 1. So in this scenario, you will always pull bandit 1 because you've got reward 1. So this guy is currently 1 and this guy is currently 0. So you always pull bandit 1. Okay, and you're happy. Maybe you're getting a 70% average reward, but you'll never know about the better restaurant next door. Okay, and so in some sense, you might be happy, but we have to now find a way of defining what optimal actions are. Okay, and can you be happy even though you don't know that there's something better next door? So you're happy, you're satisfied with A. Okay, but is this optimal? In what sense is this optimal? Well, it's good for you since you're happy, but we can define something called regret, which is, how much happier could you be? And we would like people's regret to be 0 or close to 0. Okay? And so if you stick with this bandit, okay, in the long run forever, then, you'll get an average reward of 0.7 in the world where this is 0.7. And you could have been getting an average reward of 0.9 in the world where, bandit 2 is better. And then you have a regret of 0.2, and that will amass as you pull more and more. And so in that sense, we say that strategy is not good. It could be very bad. And if you play this game many times, your regret can grow arbitrarily large. Okay? So, is there a strategy that can in sort of allow us to experience recent rewards when they're available for the plucking, but also make sure that in the long run, our regret is 0? Okay? And the idea is that deterministic strategies won't work, but a randomized strategy for reinforcement learning will work. And here's the sort of main flavor of such an algorithm. Okay, so the main flavor is, that's nice that your average reward here is 1 and your average reward here is 0. Okay, and you should exploit that knowledge. So you should be more inclined to eat here, to eat in restaurant A or to pull bandit 1, but not always. Okay, so a strategy that we can prove works well is, at every step when you're about to take an action, look at the historical average reward for all your available actions and pick the best. So pick the best with probability 1 minus epsilon. And pick a random action, and that looks very risky. But, that's what you have to do to allow for the fact that rewards are random. Okay? And so you could get unlucky sometimes. But pick a random action with probability epsilon. And we can let the probability that you pick the best action versus a random action depend on time. So epsilon of t. Imagine time steps 1, 2, 3, and so on. Okay. Now, when you pick the best action, it means that it has to be the best with respect to some data that you have already amassed. So that's your experience. Pick the best with respect to your experience. Okay. Pick a random action. Doesn't matter what your experience is. Anyone can pick random action. So eat at a random restaurant with some probability, epsilon, which typically is small, and pick the best action, okay, with probability 1 minus epsilon, which is typically large because epsilon is typically small. Okay. This is what we call exploitation. Exploitation of your knowledge. Okay. Exploitation of your knowledge. This is what we call exploration of your environment. Exploration of your environment. Okay. And it turns out that you cannot do good reinforcement learning in sort of typically arbitrary environments, in generic environments, unless your strategy includes some amount of exploitation and some amount of exploration. And in this scenario, the way that would play out is you maintain the average rewards of both bandits. Okay. whichever bandit has the higher average reward, I'm going to pick with probability 1 minus epsilon. With probability epsilon, I'm going to randomly choose. Okay? So what that accomplishes is every now and again, you'll try the worst strategy just to check, just to explore, just to peep, to see, was that strategy looking worse just by chance, or is it truly worse? Okay, so you're sacrificing a little bit by not acting greedily. Okay. This is sometimes called myopic. So the exploitation strategy, the exploitation part of that is pick what's myopically best. Okay, what you think is best based on your current, and this is sort of the more far-thinking strategy where I'm saying, you know what, I'm more interested in, what's going to happen to me later on where I really need to act optimally. So it helps me now to explore so that I build more data about the other choices I have. Okay. Exploitation versus exploration. It's a fundamental, ingredient into good reinforcement learning. And why do I say good? Because we can prove a theorem. Providing that your exploration goes to 0. Okay, so what that means is that sooner or later you have to say that, I've got enough data, I'm going to now be greedy from now on. So let's say at age 40, I have now figured out how to act optimally, and I just act optimally, low risk. I transition to low risk as I get more and more experience. Low risk means I take the optimal action given my current information. So providing that the epsilon goes to 0 with time, so you gradually decrease your exploration, and providing that the sum of epsilon of t goes to infinity. So what this means is sum over t. What this means is that, over the long haul, you will have done enough exploration to collect enough data, and providing that you have significant interest in also long-term reward. Long-term reward is important. Then your regret will approach 0. So in other words, you can reinforcement learn to optimal actions, providing you explore, okay, but then you gradually stop exploring. Okay? And that's necessary because at some point you need to start exploiting the best actions if your regret is going to drop to 0. So you gradually stop exploring, but you must have had enough exploration so that you do indeed know what the best actions are. Okay? So this is fundamental trade-off between exploitation and exploration. You need enough exploitation and also enough exploration. You need enough exploration so that you can know what's right. And you need enough exploitation so that you benefit from what's right. Okay? And that's reinforcement learning. That's the crux of reinforcement learning. Let's do an application. And this application is more for fun. Also, it's relevant to many of you who are going to be facing job offers soon. Okay, and it illustrates very well the online nature of reinforcement learning. Okay, and the online nature of the decision task that you have to make when you're doing reinforcement learning. Okay, so let me erase, and we'll come back and do an example of online decision making.